Hi everyone, today we're working on solving systems of inequalities. So remember, solving means we're going to have a solution. Systems means we have two or more. And we've been working with equations, but today we're going to work with inequalities. So remember, inequalities is where you draw the line and then you either shade up or shade down. Right? So we're going to solve systems of inequalities. The first step is going to be to graph each inequality. So remember that we want a solid line if it has a line underneath it, that equal sign, if it's equal to, so greater than or equal to, or less than or equal to. And then we want a dashed line if we have no equal sign, so greater than or less than. So that's our solid line and our dashed line. And then we want to shade up if it's greater than. So if it's greater than, so greater than or equal to, both of those, we want to shade up. Right? And then we want to shade down if it is less than or equal to. So less than or equal to. If you want a reminder on this one, go back to our last video on graphing inequality. So we're gonna graph, and we're gonna remember solid or dashed, and then shade up or shade down. And then second, we are going to find what's called the solution set. And the solution set is where the shading overlaps. So let's say we had a pink line that goes like this, and we were shading down like that. And then let's say we had an orange line that was like this, and we were shading up, maybe for the orange one. The solution set is where the two overlap, right? So where they overlap would be this section right here, right? So this would be called the solution set. Section. Cool. So we're going to do two examples. The first one looks like this. It says solving a system of inequalities means finding the ordered pairs that satisfy all of the inequalities in the system. So ordered pairs, that's like x comma y, right? We're going to find the solution set where the points are. So first, I need to graph them. So I'm going to go ahead and graph this one first. It says -4, that's my y-intercept. So on the y-axis, going to -4. And then it says -2x. It's my slope. So -2 is a whole number. I'm going to divide it by 1 to make it a fraction. So rise over run, down 2 over 1, down 2 over 1. So down 2 over 1, down 2 over 1, down 2 over 1. I don't just want to go one direction, though. I want to also go backwards. So up and backwards, up and backwards, up and backwards, up and backwards, all the way to the top of my graph. Then I'm going to check the sign. So I'm checking the sign. There is no equal sign there. So this is going to be a dashed line, right? Since there's not an equal sign. So I'm going to do dash, 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 dash. I'm going to make sure that I have arrows at the end always. So it's a dashed line. And then this is less than, y is less than. So since it's less than, I'm going to shade down. So I'm going to go to a point, shade down, 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 right? And so I can see, okay, it's this side that's supposed to be shaded. So I'm going to shade it all on this side over here. Everything all the way up to the line. So that is my shaded side for the red. Okay. Then I'm going to go ahead and graph the blue one. Do this one here. And I notice, first and foremost, that's not set equal to y. So I'm going to go ahead and solve that first. So I want to get y by itself. So I'm going to subtract x on both sides. So I have 2y. I'm going to put that x first and then the 6. So it's less than or equal to -x plus 6 because it was a positive 6. And then I want to divide by 2 on everything. So here I would have y is less than or equal to, remember there's an imaginary 1 here, so -1x over 2 is like -1/2 x. plus, and then 6 divided by 2 is 3. So now I have y equal to, or y isolated by itself. I'm going to go ahead and graph it. I see a positive 3 for my y-intercept, so I'll graph that. And then I see negative 1/2, so down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, 1 over 2, all the way to the edge, and up and backwards, even through that red section. Okay. I see that this has an equal sign on the bottom. If I'm looking at this equal sign right here, see that it has an equal sign, so I know that this is going to be a solid line. I'm going to go ahead and graph it. Try to draw it as straight as I can. Put arrows on both sides. And then I see that y is less than or equal to. So I'm going to go ahead and shade down. Right, so I'm going to go to a point, shade down, shade down, shade down, shade down, 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 like this. Okay. So I graph my two lines, both of them. I will be careful for my less than and greater than. I'm careful for solid line or dashed line. And I have my two equations. And I see that there are 4 sections that this creates. It creates like one little baby section, this part here, a second baby section right here, a third section right here, and a fourth section right here. I want to look for the section where both colors are overlapping, right? Both colors are overlapping. So the section where I see both colors are overlapping is in section 4, right? So this section right here, right, is where both colors are overlapping. So I would draw an arrow to that section and I would say that this is my solution set. That's my solution set. So any point that is in there is going to be a solution. So this is a solution, 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 this is a solution. This is not a solution. This is not a solution. This is not a solution, right? So solutions are only found in the solution set. They're only found where the two colors are overlapping. So I could say this point right here, whatever that point is, 1, 2, 3, 4, 5, 6, 7, 8, -8, comma, 3 is a solution, right? Because that point right there is inside of the solution set. And then if I went over here, maybe you selected this point, that's like 4, 4. 4, 4 is not a solution. Right? So like this point is not a solution, 0, 0 is not a solution, anything up here is not a solution, right? The only parts that are solutions are what is in number 4. So in IXL, you don't even want to color in this section here, and you don't want to color in this section here. You only want to color in this section right here. That is the only part of our solution set. So in IXL, all the other ones are going to be white, and just that one is going to be the one that you select. All right, we also have one more. Let's go ahead and look at this one. It says separate regions. It is possible that the regions do not intersect. When this occurs, there is no solution, or the solution is the empty set, and we mark the empty set like this, with like a little circle with a line through it. So let's see an example of this. I'm going to graph this first one, starting at +5. And this is 1x, so 1 over 1, up 1 over 1, up 1 over 1. So up and over like this, down and backwards, all the way to the edge. I'll draw that line. Wow, terrible line. Let's try that again. Still not awesome. All right, here we go. There we go, much better. Third time's a charm. So we have the pink line there, and I'm lucky that it has a equal sign there, so that means solid, because I totally forgot to look at that. Solid first, And then this is greater than. So y is greater than. So we're going to shade up. So with my pink, I'm going to go ahead and shade up. Cool. For the second one, I'll graph it in purple. I'm going to start at -4. And this is 1/1 as well, a parallel slope. So up 1/1. Notice I started to do 2/2, that's the same, right? This one does not have an equal sign, so this one is dashed. So I'm going to go ahead and dash, 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 making sure that I have my arrows on both sides, showing that it goes forever and ever. And then this is a less than, right? It's less than, pages away. So we're going to shade down. So I'm going to go ahead and shade down like this. Notice that they don't touch. There's no place where they interact, and they're never going to touch because they're parallel, right? So one will always be on top and one will always be on bottom. And so this is what we would call an empty set. We could call it that. You could show it like this, or you can say no solution. That's probably the one we're most comfortable with. Right? So no solution. So we would say anything that's in this region, right? That would be a solution. And anything that's out here is not a solution. Anything, there's no solutions to this one because there's nothing where it overacts. All right, you're gonna get started on your assignment now. Thanks, guys.